This microphone, okay, yes. So we have here different resolution ranges. So you see 2 to 5 meter resolution is served by several commercial satellites, and there are more and more of this type. And here we can derive certain products, so suspended matter, turbidity, secondatives, some of organic absorption. So that's not really chlorophyll, but there you can derive again indicators from that. Then we have a high resolution range from 10 to 30 meters, which is covered at the moment between 6 and 10 times per month. And each year we have an increasing number of satellite sensors, especially in this resolution range. So we have here different sensors which are capable to do that. And then we have the medium resolution range, so about 200 to 500 meters. There are again, MODIS is the most well-known, Aqua and Terra 2 satellites, satellite 3 will come up. So there will come up also more in the upcoming time, and also several nations, India, China, have of course further satellites that can contribute here. And here we have more satellite products that can be derived. And the important point, we have here actually already between 2 and 2 coverages per day, up to 2 coverages, and this number will also increase. But on the other side, we have also clouds. Of course, so we have different varying environment conditions that need to be accounted and to corrected, or at least then to identified and masked out, then if it's no further possible. So this is this is a very 2 meter resolution of the island in Western Australia. So we have to correct as far as possible, because atmosphere varies always, so we cannot assume that this is constant. So this is aerosol optical depth that our processors retrieve from this imagery, and in order to correct for this, and this would be then the corrected imagery. But still, if you go back here, well, these things here are almost a cloud. So there's a transition, and up from a certain point we will mask it out and say it is no further feasible. But you will directly understand that under this, that here we have different accuracies than that here where we don't have any haze. So we need to identify and quantify this impact in order to give also certainty measures or uncertainties to all these million measures that are then done with just one satellite image. Saying that there are, just to draw to another impact, there are several impacts. So this is chaos, so imagery, so from Gesta, Thailand, from Mekong Delta. So you see here the plume entering into the sea from the Mekong River. There are other impacts if you go to high resolution imagery to the coast and to inland waters. There are many further impacts to be accounted for. Just to remind that there's in-atmosphere scattering, not only from scattering one time scattering in atmosphere, but multiple times, so that the light is reflected on the land, reflected then scattered in the atmosphere, back scattered to the sensor. That means if the sensor looks down to the water, there's also an impact on the adjacent land. This looks like that. So that's just for the water areas. You see here, if you go to the offshore regions, there's no further low impact of the land. It goes up to 50 kilometers. And as closer you come to the shore and in the rivers, there's more impact on the land scattering. So if you don't correct, then this would be the turbidity map. If you correct for this, turbidity is much lower. And so now, again, to get harmonized products, you have to account for this, because otherwise your measures in the rivers would be too high in relation to offshore. Yes, I think that's more or less enough to learn what different environmental impacts are there and can and will have an impact on the accuracies, and needs to be corrected in order to get still good values. So clouds, atmosphere, water surface, sun glitter, you will see it directly if you are standing next to a lake or the sea and see the glitter if you are looking towards to the sun. So, and we have also the natural variability of the water constituents, optical properties, of course. So we need to correct for these things, and where we reach the physical limits, then we have to generate, of course, uncertainty estimates to know that still what the accuracy or approximate of the value to retrieve, but the objective is harmonized information on multiple scales. So we have a generic processing system developed over many years, so it goes even back up to 20 years as we started this development at the German Aerospace Center that corrects for all these things, so for bidirectional things, for atmosphere, for surface reflectances. And this is sensor independent, that means as soon as the new space sensor is launched and available, that we can also process this. For application, that means that we have each year an increasing temporal and spatial resolution that can be served by satellite sensors. For your conditions here in Singapore, it means that where you have very cloudy conditions, here you must capture as many images as possible, because always during the day you will have varying conditions, and sometimes the day there is the time when you have also good conditions. If you combine all this, you have better opportunities to get also values in here. Well, I will start with applications with bathymetry and seafloor mapping to give you some ideas of different projects, how this looks like, and then continue with water quality. So this is a satellite scene world view 2 meter resolution from Mexican coastline. It's Yucatan coastline. So here this is the raw data. This is an intermediate product type. This is a subsurface reflectance. So if you would snorkel, or if you would have a radiometer under, just below the underwater surface, that's the reflectivity under the water. It's an intermediate product. This is the bottom albedo, so the reflectance of the seafloor. And from this we can then do spectral classification as we do it also on land, and then finally derive two different types of products. So one is the seafloor habitats, if you relate to spectral classes with habitats, and on the other hand side water depths. Because it has to be, for physical reasons, we have to solve this in one step, because we cannot discriminate or analyze the spectrum for bathymetry independent from the seafloor, for example. So we do this, for the whole Yucatan coastline down to Belize. For Conabi. Conabi is the Center of Biodiversity under the Ministry of Environment in Mexico. They start doing mapping their whole coastline, because of course it's so far not possible to get a really total view to the environment if you only do this with divers for such large scales. So finally here, then to go to the habitats is a combination, the most effective thing is a combination with a certain ground truth concept and the satellite based mapping. Yes, another example for island Qatar. Here I'm not yet allowed to show the product itself, but it is a company Shell, where we mapped 600 square kilometer for bathymetry. It was used for offshore planning of further surveys of the eco-sounding surveys. The savings that they retrieved here were $1 million US, and so they could much more effective to do the planning for the very accurate eco-sound soundings, but they could already map the whole area of the environment here, and so the product delivery just took 2 weeks time. That means it is very quick, and you cannot mobilize so fast ships or lighter airborne sensors. So that's of course very good, especially in planning phases. That's another area around Qatar, just to give you an idea that these maps can look like also like standard hydrographical maps. So it's like the isolines of a hydrographical map. So we did so also for NOAA, so the US National Oceanic Administration. Here is this is US Virgin Islands, so we did different islands for them. And it's again the bathymetry what we retrieved here. So you see here they wanted to test this methodology, and so you see here historical bathymetry data that we then compared with the satellite data. And these were quite clear water conditions, so here we can go up to more than 30 meters, retrieve still information up to more than 30 meters. Beyond